Hello everyone, my name is Fuping. Here I would like to present the details of the paper with the title Multi-modality cardiac segmentation while mixing domains for unsupervised adaptation. For domain adaptation, previous work were mainly for single task domain with one or more source domains. However, in practice, multi-unlabeled datasets from different centers are usually available, while multi-source data are less accessible. So, we may doubt that, as images from different domains could contain complementary information, such as the anatomical knowledge uncovered by CT and MR cardiac images. If this data could be utilized together to boost the performance of the model on each target domain. In this work, we simply discuss the most intuitive way of data mixing. That is, this work discusses the mixing technique for unsupervised domain adaptation problem with multi-target domains, as illustrated in this figure. We mix the two or more target dataset together directly as one target domain. To validate this strategy, we employ the variational approximation framework for domain adaptation. This method was published in the journal TMI. It consists of three modules. They are the encoders for feature extraction, the extractors for image restoration, and segmenters for semantic segmentation. For the source and target data, we would have the evidence lower bound as equation 1 and equation 2 respectively. As the objective function, in these equations, Qs and Qt denotes the posterior of the features given the images, and they are modeled by the encoders. PS and PT are the posterior of the images given the features. They are modeled with the reconstruction modular. In order to align the two domains in the latent feature space, we introduce their L2 long distance as the measurement of their distribution discrepancy. The distance can be formulated in equation 3, and its kernel function is presented in this formula, which is similar to Gaussian kernel. Adding the segmentation loss, we have the total loss function as equation 4. For validation, we use BSSFP CMR images as the source domain and LGE T2 CMR images as the target domain. The dataset is provided by the Xiahai 2019 Multi-sequence cardiac MR segmentation challenge. However, for multitask dataset, such as the 3 MR sequences, we might have the prior knowledge about their anatomical covering. We know that for BSSFP, T2, and LGE CMR images, they covered different areas of the heart, with some parts overlapping. We argue that different label distributions could lead to totally different results. For convenience, here we just discuss two simple situations. The first one is that the target neighbors are complementary with regard to the source domain. It means that their mixing neighbors are similar to that of the source one, while the target neighbors themselves are significantly different. For this situation, we select the slices of the LG images close to the basal point, and the slices of T2 images are close to the apical slice. The second situation is that the neighbors are similar for all domains. We investigated two situations with the aforementioned framework. We discussed the argument with the results of LG images. We conducted two SOTA methods, PNP, ADANET, and VADA, which is a variational approximation framework. And then we mix the target data to see if the mixing strategy is useful using this method denoted as MXVDA. Table 1 shows the results of LG CMR in the former situation. We concluded that the mixing strategy could benefit the segmentation of unsupervised domain adaptation for this situation. Comparing the results of MXVDA to VADA, and Table 2 provides the results of the latter situation. It can be concluded that the mixing strategy could degrade the performance. And that's all for my presentation, and thank you very much for your time.